So, an electric dipole consists of two charges, plus 1 millicoulomb and minus 1 millicoulomb, separated by 4 into 10 to the minus 2 meter. If the axis of the dipole makes an angle 60 degree with the direction of uniform electric fields of strength 10 to the 5 Newton per coulomb, then find the torque experienced by the dipole. So, torque acting on the dipole, in a uniform electric field, is given by tau equal to P. Okay, tau equal to P sin theta. Here the electric dipole moment P equal to Q into 2A, okay, which is the electric dipole moment, or Q equal to given as 1 millicoulomb, or this is equal to 10 to the minus 3 coulomb, into the separation between two charges is 4 into 10 to the minus 2 meter. 4 into 10 to the minus 2 coulomb into meter, or this is equal to 4 into 10 to the minus 5 coulomb into meter. Okay, and the electric field intensity E is given by, so electric dipole moment P equal to 4 into 10 to the minus 5 coulomb into meter, and E equal to electric field intensity E equal to 10 to the 5 Newton per coulomb, and the axis of the dipole makes an angle 60 degree with the direction of uniform electric fields, so theta equal to 60 degree. Okay, therefore the torque acting on the dipole is given by, therefore tau equal to, put the values of P and E and theta. P equal to 4 into 10 to the power minus 5 into E equal to 10 to the 5, okay, into sin 60. So this is equal to 10 to the minus 5, 10 to the plus 5 cancel. This is equal to 4 into sin 60 equal to root 3 by 2. This is equal to 2 root 3 Newton into meter. So the torque acting on the dipole is 2 root 3 Newton into meter. Okay, this is the answer. Okay. So another question given that an electric dipole consists of two charges, 10 microcoulomb and minus 10 microcoulomb, separated by 5 into 10 to the minus 3 meter. Calculate the electric field intensity on the axis of the dipole at a distance of 15 centimeter from the midpoint of the dipole if it is a short dipole. So electric field intensity due to an electric dipole on the axial line is given by E equal to 1 by 4 pi epsilon 0 into 2p by r cube. Okay, 1 by 4 pi epsilon 0, 2p by r cube. Here P equal to Q into 2A. So this is equal to Q is 10 microcoulomb. So this is equal to 10 into 10 to the minus 6 coulomb into separation between them is 5 into 10 to the minus 3 meter. 5 into 10 to the power minus 3. This is equal to 5 into 10 to the power minus 8. Okay. This is equal to coulomb into meter. Okay. And R is given as R equal to 15 centimeter or 0.15 meter. Okay. Therefore, E equal to 1 by 4 pi epsilon 0. So 9 into 10 to the 9 into 2 into P equal to 5 into 10 to the minus 8. Okay. Divided by RQ. RQ equal to 0.15. Q equal to, when you will solve it, you will get 2.6 into 10 to the 5 Newton per. Okay. So the value of E is found to be 2.6 into 10 to the 5 Newton per coulomb. So an important question. An electric dipole consists of two charges, 2 microcoulomb and minus 2 microcoulomb, separated by a distance 5 mm. The dipole is placed in a uniform electric field of 4 Newton per coulomb. If the axis of the dipole makes an angle 30 degree with the direction of the electric field, then calculate the torque acting on the dipole. So torque acting on a dipole in a uniform electric field is given by tau equal to Pe sin theta. Okay. Here P is the electric dipole moment. P equal to Q into 2A. Q equal to 2 microcoulomb and the distance 2A each 5 mm. Okay. And theta, the dipole is makes an angle 30 degree with the direction of the field, that is theta equal to 30 degree. Okay, and E is given as 4 Newton per Coulomb. So putting all these values, we will get here P equal to Q into 2A, which is the electric dipole moment. So Q equal to 2 into 10 to the minus 6 into 2A is 5 into 10 to the power minus 3. Okay, so 5 millimeter or 5 into 10 to the minus 3 meter. This is equal to Coulomb into meter. This is equal to 10 to the power minus 8. Okay, 10 to the minus 8 Coulomb into meter. The value of E, electric field intensity E, equal to 4 Newton per Coulomb, and theta is given as 30 degree. So tau equal to torque acting on the dipole, tau equal to P E sin theta. The value of P, electric dipole moment, is 10 to the minus 8 Coulomb into meter, into E is 4 Newton per Coulomb and sin 30. Okay, so this is equal to sin 30 equal to half. So 10 to the minus 8 into 4 into half equal to 2 into 10 to the minus 8 Newton to meter. So the torque acting on the dipole, tau equal to 2 into 10 to the minus 8 Newton to meter. Okay, which is the answer.